All right, so here is a problem where we have a unknown side of a triangle. At the beginning, I set up the problem here by saying that's going to be 22 and that's going to be 8. There would be a number right here to make it a perfect right triangle, and that'd be easy to find because it would be a right triangle and it would follow all those rules. You'd have a right triangle where you have an angle and a side. It'd be easy to find that. Well, if you find that, you'll find out that 7, which is what I want you to use, is not that number. It's longer than the number that would make a right triangle. So then it's not that complicated if I just say here's a triangle and it's got a side of 8 and a side of 7, and this is 22. It seems like it should be a really easy question. You already know 2 sides and an angle, and it should be easy peasy to find its area, which is one thing I want you to do, and to find how long its base is. That should be pretty easy. The weird thing is that there's 2 answers. Why is there 2 answers? Because this side of 7 here could swing the other way and be over there and be a side of 7. And then the area is a lot bigger area, and the base down there would be a lot bigger too. Okay, so here's my hint for you that's huge, is I draw in this isosceles triangle that you would get if you swung it both directions. Once you draw in that isosceles triangle, if you know this angle and this angle have to add up to 180, it won't be hard at all to figure out what all the angles have to be. Once you got all the angles, then it won't be hard to figure out what's this base, that's the small version of the base, and then what's this base, this black line all the way across here. How long are those 2 different bases? And then what are the areas? I'll pause for a minute while you finish this up. If you do nothing else, please try to figure out that angle right there. And if that angle comes out really strange, maybe because it's actually this angle that you're figuring out. All right, I'm going to pause again. Okay, now we're in the part where we're talking this through. I am trying to find that angle that's got the arrow to it that's across from the 8. And so I'm going to enter some info in my calculator here. Pausing. Okay, after doing this perfectly, I did my inverse sine of 0.42 something, and I get an angle of 25.3. Do you get how that really messes with your head? That can't be 25.3. It's a big obtuse angle. It's because of the nature of inverse sine. You'll learn this later in this chapter. The inverse sine answers can only come out less than 90. So it's actually giving you this angle. 25.3 degrees is that angle. If that angle's 25.3, then this must be 25.3. And then I can figure out that one must be 180 minus that. And I get 154.65, 154.7, let's say, degrees is that one. Okay, now that I've got those angles, I got this angle and this angle, which are equal, and this angle, which is really big, now I can figure out everything. Because this side is 7 still, because it was just the same side as this swung over there. And now I can figure out this base of this triangle, the big one. I always do that, but I'm going to try that again. All right. Who has the long base? Raise your hand if you think you got that. Yes, sir. What do you think? Can anybody verify 13.76? All right, excellent. And how about the small base? This little one right here. Must be way less than 13 by the way it looks anyway. Yes? Can anybody verify 1.09? Quite a few people. Okay, good job. All right, then to find the areas, of course, we can either use heroes, which is that semi-perimeter thing, but since we have the angles, it's a lot easier to just use the side angle sandwich thing and say, here's a side, here's an angle, and I do 1/2 AB sine C, and I can find the area of the small one. The area of the big one, this side, and the same angle, and it'll give me a much bigger area for the area of the big one. All right. So there's the ambiguous case, and it's always worth talking about because it's so confusing how you're doing the law of cosines or the law of sines perfectly, and that angle's coming out to like 20, and it's like, that can't be 20. All right, so then that means you're getting its complement, and it's because of how inverse sine works. Inverse sine can only give you answers that are less than 90. So if the answer is bigger than 90, it's giving you this other triangle that's possible. It's the indeterminate case. All right. So this is the day before the test. So is there anything else from chapter 11 that you would like me to talk over? Any other types of problems that have bothered you? If you don't think of anything, I can think of one more that we could do, but I'm willing if you have a question. Okay, then let's talk about the bearing question because it gets people every year, all the time. Let's do one simple bearing question. All right, we're going to start in the lower left-hand corner, and this is going to be a boat, and it's going to be heading at 40 degrees true bearings at 100 miles per hour. It is a cigarette boat flying across the lake. Question? 100 miles an hour doesn't seem possible to you? They go really fast. You never heard of a cigarette boat? Okay, they're long and they look like a cigarette. They're really long and they got a huge engine that just rumbles. And you don't see them out in Lake Minnetonka all that often, but there are a few out there. They're the big race boats. Anyway, so then that boat, its position would depend on what? Its speed's already fixed. Time. All right. So let's say that we're going for a half hour here. He drives that way for a half hour. Then his engine quits. Runs out of gas, whatever. Something fouls up and the engine quits. So he's stuck out there and he starts to drift. Just for a half hour. If he starts to drift then, and let's say that the wind is blowing in such a way that he ends up going at a bearing of 110 degrees. And let's say he drifts for 1 mile. The question is, if somebody's going to now fly with a helicopter back from home here, what bearing should they take to get to him? What is the bearing from home to him? Okay, give that one a shot. I'm going to pause for a second while you do. Okay, given that we don't have that much time, I'm going to start it. If you're not done, that's okay. I'm just going to get some of it done. That's 40. I like to label all the sides in my original compass rose, except the 90s, which are obvious. Okay, so if that's 40, that must be 50. Next, he stopped somewhere. How far was he? Well, 100 miles an hour. If you put 100 on the side, classic mistake. You don't put 100 on the side. He went 100 miles an hour for a half an hour, which means he went how far? 50. And if he's at 50 and he starts to drift, then he's going to go from here, another compass rose, 110. So let's say that. And if that's 90 to get to here, then 110 must be 30 more degrees. That's a 30-degree angle. That's, of course, a 90. And then this must be a 60. All right. And it's only 1 mile. Yes. Did I do something wrong? 90, 100, 100. You're right. Sorry, that's a 20. Oops. Thanks for catching me before I went too far. Okay. 20. Now, does scale matter? Yes. If you go and say, well, you drifted for a mile, it's going to look like you're going to head straight, east. But if 50 and 1 stay in relatively, like this one's 50 and this one's 1, I should probably make it even shorter. But as long as I get the idea that this angle that the helicopter is going to take here is kind of in the neighborhood of, 45, something less than 50, I can tell you that. Oh, wait, going this way, sorry. 40 plus something, so probably something in the neighborhood of 50 or so degrees. If I get generally the scale right, that's important. Okay, now I'm going to try to do that whole transfer thing. That gets transferred over to here, so that's 40. And if that's 40, this is 50. Why does that matter? Because now I can get, that must be 50, because, no, that wouldn't make, it must be 70, sorry. 70, so I'll make a total of 90. 70 and the 40 makes 110, and why does that matter? Because now I got a side angle sandwich. I've got a side angle side situation. I got a 50, I got 110, and I got this side, which is 1. And I have an angle and side, an angle, side, angle, side. That works really well for law of cosines. Can't do law of sines because I don't have a side and the angle across from it. Now, that'll help me find this side length. But in the end, to get these problems, you almost always have to get these triangles around the outside. This triangle here is a right triangle in which I would know a side, the dotted line, this green dotted line, I would know that side length from doing law of cosines. And it's a right triangle, and this angle's, actually no, I don't know that angle's 50. Oh, I remember. I can find one side of this, and then I can find the other side of this, and then I will know what this angle is. That'll be a big deal. As soon as I can find that angle, I'll have my bearing. So how do you get this side and this side with the other right triangles around the outside? So here's one more right triangle around the outside. It's a little tiny guy. That's a right triangle. And I know one side, and I can know an angle. And then here, my last one. And I would know a side of that one, the hypotenuse. And I'd know an angle. This is 50. And again, if you know a side and an angle, you can find out anything. Now, I like to call these L1 and L2 adding up to L3. And this one, I would call this H1, the smaller one, and H2, adding up to this big one, H3. And I would know 2 out of the 3. All right, enough talk about those. Those are the toughest kind of questions you have to hit. And you got law of cosines, law of sines. You got, a couple formulas, heroes with the semi-perimeter. Make sure that you have done your homework, because during your tests, I really want to get something in the grade book. So I'm going to say, okay, everybody, here's the one I want you to drop in a Dropbox for me. Have your homework done for the last several days, and I'll pick one and throw it in the Dropbox tomorrow. That's all I got for you for today.